Righto, science students, let's have a go at question 2 off the Criterion 5 test for motion and force. So we've got a hockey player striking a hockey ball. In part A, we're asked what distance does the hockey ball travel while it's in contact with the hockey stick? Okay, so it's accelerated motion. We're told some information here, so let's use Suvat to write this stuff down. Actually, I just prefer to do this with a blue pen, I think. Okay, so remember, if in doubt, Suvat. Okay, so what distance does the hockey ball travel? Well, that's what we're trying to find, is the displacement or the distance, S. Now, this question was it does sort of assume that the hockey ball is at rest. It really probably should have said that, but it didn't. But we're assuming the hockey ball starts at rest, and then it gets a whack from the hockey stick. Right. So the velocity, well, we can see here that it's given a velocity of 28 meters per second to the north. So that's our final velocity after the strike. And the acceleration, we're told over here. Now, this is actually an exponent there. So we got 1.98 by 10 to the 3. Now, that's equivalent to 1,980 meters per second squared to the north. Okay, so you can either leave it as is, or you can convert it to a number in standard form. Right, and the time of the strike, do we know anything about that? No, we don't, but I don't think we really care. Right, so in this case we need to use the equation of motion that omits time. So we're looking at v squared equals u squared plus 2as. Okay, now you need to practice your rearranging. So make sure that you understand how to rearrange this so that it looks like this. Okay, so it's something we've practiced a bit before. Alright, so we go ahead and put these numbers into our equation. Okay, if you put that through the calculator, you should get 0.198 meters. Not that you need to convert this, but that's 19.8 centimeters. Okay, so that's part A. Now, one number we didn't utilize previously was the mass of the hockey ball. So that's going to come into it now, is this mass of the hockey ball. So we're asked to calculate the magnitude of the force by the stick on the hockey ball. So remember Newton's second law, force equals mass times acceleration. Okay, so in this case the mass is given in grams. That needs to be converted to kilograms. So that's 0.220 kilograms. And the acceleration, as before, 1,980 meters per second. So if we put that through the calculator, we should be getting 435.6 newtons. Going to three significant figures, we'd say 436 newtons. Now, not going to give a direction here because we're just asked for magnitude. Of course, this is in the direction north, but we don't need to worry because we're just asked the magnitude. That means we just need to give the size of the force. Okay, change in momentum of the hockey ball in part C. Okay, so remember, change in momentum is equal to mass times the change in velocity. So this is basically mass times v take u. Okay, so this case we've got 0.220 multiplied by v take u, so 28.0 minus 0. And if we put that through the calculator, we get 6.16. And we've got kilograms, meters per second. Now in this case, we're not asked only for magnitude, we're asked to find the change in momentum, which is a vector. So we need to give the direction, and that change in momentum is in the direction that the ball is struck, so to the north. Right, now calculate the time of impact using the concept of impulse. Okay, so impulse is change in momentum, right? Now, in that case, if we look at the change in momentum, that's what we have back here. So impact, change in momentum. Now, because this question asked us to show do this using the concept of impulse, I'll go through it from that point of view, right? So impulse is a change in momentum. So if we look at change in momentum, right, that's equal to 6.16 kilograms meters per second to the north. So of course, we can always look at change in momentum like this. Is mass times change in velocity. Okay, now we could equally say, okay, let's divide these both by time. And that means that we now have change in momentum over time equals mass times acceleration. So where does that come from? Well, we know that change in v over t is equal to acceleration. So we know the change in momentum is 6.16. Time is what we're trying to find. The mass is 0.220 and the acceleration is 1980 as before. So by rearranging this, we get that t is equal to 6.16 over 0.220 by 1980. And if we put that through the calculator, I'm just going to check this because I've only checked this in a different way, which I was okay with you guys doing it that way. I'll just explain in a moment. But 1980, and yeah, we get that answer, right? Now, look, guys, to be honest, I thought this question was a little bit tricky, so I wasn't worried. So long as you got the number, right? And the easy way to do this is like this, right? We just use suvat. So we're going to go and write these things down. Okay. So we know the time, we're trying to find the time of impact. Acceleration 1980. Final velocity is 28.0 and the initial velocity is 0. Now, we did calculate this S before, but I'm not going to worry about it here. I'm just going to use V equals U plus AT. And most of you guys just went, who did get this correct, just went down this path. And I was happy for you to do it this way. I thought that this way I explained up here was just a bit much. So if you could get the number doing this by rearranging and we get V take U over A, I was more than happy to accept that. So if you're wondering why you got full marks, despite not doing it the way that I just showed above, that's because I was feeling that it was a bit much to expect. So anyway, technically, and maybe in the exam if they say this, well definitely in the exam if they say use the concept of impulse, they're going to want you to do it like this, right? But for our situation here, I was happy for you guys to go down this path and get it that way. Okay guys, so once again, if you had any parts of this that you weren't able to do, please go back through those and see if you can manage to get them now.